For our first example, let's find the Laplace transform of t times the sine of kt. Of course, we already know our function is f of t is sine of kt, and that has as its Laplace transform k over s squared plus k squared. We've seen that in the past. But n equals 1 in this case, so the Laplace transform of t to the 1, that's why n equals 1, sine of kt, is negative the derivative of the Laplace transform of sine of kt, which is the derivative of k over s squared plus k squared. Negative, sorry, the derivative of k over s squared plus a squared, which is quotient rule. Down, d up, well, d up is 0, minus up, d down, so minus k times 2s, and it's minus a negative, so it's plus 2ks over the denominator squared. If you want to hear it one more time, it's low d high minus high d low over the square of what's below. And if we do that, then we get negative 2 times k times s over s squared plus k squared squared. And that is the Laplace transform of t times sine of kt. So just to get the hang of this a little better, let's do the Laplace transform of t times e to the 3t two ways. Okay? See, we could be finding the Laplace transform of t and then replace s with s minus 3, or we could find the Laplace transform of e to the 3t, and since there's a t here, take the derivative of that. So how about that for cool? We can do this one either way, looking at it as t times e to the 3t or as e to the 3t times t. So one way, looking at this as a translation, sorry, of e to the 3t by 3, so it would be, say, well, it's the same as the Laplace transform of t, which of course everyone knows is 1 over s squared, but with s replaced by s minus 3, so it's 1 over s minus 3 squared, using theorem 7.6 from lesson 3. But the theorem we just had up here, we could say, well, I'm going to think of that as negative the derivative of the Laplace transform of e to the 3t. That's what the t tells me to do. That's t to the 1, so only first derivative. So in other words, we want to find the derivative of 1 over s minus 3. And actually the negative of the derivative of 1 over s minus 3, and of course you should figure out that that's like s minus 3 to the negative 1. So it's negative 1, and those two negatives cancel out, times 1 over s minus 3 squared, so it's just 1 over s minus 3 squared. Using our theorem above, and notice we got the same result either way we did the problem.
Oh, I see.
Good.